Hello everyone, I'm Mr. Chen. Today we'll keep learning electrical. Today we'll focus on Project 3, the electrical main wiring. And today's goal is to understanding the concept and classification of electrical main wiring, mastering standard figure symbols and word symbols of various electrical equipment, master various wiring forms, advantage and disadvantage and applications such as single bus wiring, double bus wiring, unit wiring, and bridge type wiring. Understanding the typical main wiring scheme of power plants. First, we'll learn about main electrical wiring concept. So main electrical wiring concept means that it's a circuit formed by connecting primary equipment such as generator, transformer, and circuit breaker through connecting wires according to their functional requirements, which is used to present the production, collection, and distribution of electric energy. It's usually also called primary wiring or main electrical system. Main electrical wiring diagram. It is a wiring diagram that uses specific words and graphic symbols to arrange and connect according to the actual operational principle and represent the basic consumption and connection relationship of electrical equipment in detail. Generally, it's done as a single line diagram, but for parts with different three-phase wiring, such as different configuration of current transformers of each phase, is drawn as three-line diagram. And the concept of it is that the main electric wiring represents the main structure of the electrical part of the power plant and substation. Collecting and distributing electric energy is an important part of the network structure of the power system. The quantity, type, voltage level, interconnection mode between equipment and connection with power system of primary equipment in main electrical wiring reflect the scale of power plant or substation and its position in power system. The main electrical wiring form plays a decisive role in the selection of electrical equipment, distribution device layout, relay protection, and automatic device configuration, and directly affects the reliability, flexibility, and economy of system operation. And the main electric wiring shall meet the following basic requirements. First is that it ensures necessary power supply reliability. It has certain flexibility, ensures safety and convenience during maintenance and overhaul. Try to reduce one-time investment and annual operation costs. If necessary, it should be able to meet needs of future expansion. And two is we'll go through the single bus connection. And this is the mainly knowledge that we will go through. First is the single bus without section. And then is single bus section. And third one is single bus section with bypass. And we'll have a little summary. So the single bus non-section wiring means that bus, also known as bus bar, plays the role of collecting and distributing electric energy. Single bus connection refers to the connection using only one group of buses. Wiring feature. Each circuit is connected to a group of buses through a circuit breaker QF and disconnector QS. The advantage is that simple and clear wiring, less equipment, convenient operation, less investment, and easy expansion. And disadvantage is that poor reliability and flexibility. In case of maintenance and failure of bus and bus disconnector QS, all branches must stop working. When the circuit breaker QF of working line is overhauled, the power supply of this branch shall be stopped. And the fourth is the scope of the application. It's generally used in small and medium-sized power plants and substations with few outgoing circuits and low requirement for power supply reliability in 6 to 220 kV voltage system. And when the number of outgoing line is large, in order to improve the reliability of power supply, the bus can be segmented by circuit breaker into single bus segmented wiring. During normal operation, there are two operational modes for single bus section wiring. First is called section breaker 0QF is closed for operation. Second breaker 0QF is disconnected for operation. And also, when the section breaker 0QF is closed, two power supplies are respectively connected to two sections of bus. The load on the two sections of bus shall be evenly distributed. The reliability is good, but the short circuit current is large in case of line fault. When section breaker 0QF is disconnected, the outgoing current of each bus can only be connected to the short circuit line of the power supply section. The automatic switching device of equipment can be installed at 0QF. Important users can connect it from two sections of bus and adopt double circuit power supply to improve the reliability of power supply. And the advantage of the single bus section wiring is that when the bus fails, only the fault bus section stops working and the other bus section continues to work. Two sections of bus can be regarded as two independent power supplies, which improves the reliability of power supply and can supply power to important users. And the disadvantage is that when a section of bus fails or is overhauled, all branches on the section of bus must be disconnected, and the power failure range is large. When the circuit breaker of any branch is overhauled, the branch must be powered off. And the scope of the application, compared with non-segment wiring of single bus, segment wiring of single bus improve the reliability and flexibility of power supply, but its disadvantages are more obvious when power capacity is large and the number of outgoing lines is large. Therefore, single bus section wiring is used in the following cases: 6 to 10 kV. The number of outgoing circuits is 6 or more. 35 to 63 kV. The number of outgoing circuits is 4 to 8, and 110 to 220 kV is 3 to 4 outgoing circuits. And a single bus section with bypass bus connection, in order to overcome the disadvantage that the circuit must be powered off during the maintenance of outgoing circuit breaker, the method of adding bypass can be adopted. You can see the pictures here. This is the main bus. A wiring mode bus. A wiring mode wiring mode with special bypass circuit breaker. The bypass bus is connected to the section 1 and 2 bus through bypass circuit breaker 90 kV. During normal operation, 90 kV circuit and bypass bus are in cold standby state. If the number of outgoing circuit is small and the utilized rate of bypass circuit breaker is not high, it can be used together with section circuit breaker. And there are the following two wiring forms. Sectional circuit breaker is also used as bypass circuit breaker wiring. During normal operation, the section breaker 0QF and its disconnectors 03QS and 04QS on both sides are in the on position, and contact disconnectors 05QS and 06QS are in the off position, and the bypass bus is not charged. Section disconnectors 01QS and 02QS can be used to repair section circuit breaker 0QF to connect section 1 and 2 buses for power supply. If the number of outgoing circuits is small and the utilization rate of bypass circuit breaker is not high, it can be used together with section circuit breaker, and there are the following two wiring forms. Bypass circuit breaker is also used as section circuit breaker wiring. Advantage is that compared with the single bus section, the single bus section with bypass wiring has the advantage that the bypass circuit breaker can be used to replace the circuit for power transmission in case of outgoing circuit breaker failure or maintenance, so that the line will not be powered off. Disadvantage is that the wiring relatively complex, and the opening and closing operation sequence is complex. And the scope of combination is that in the device with voltage of 6 to 10 kilovoltage. And 3 will go through the double bus connection. And in this section, we'll go through the sectional double bus section, double bus with bypass, wiring of 1.5 circuit breakers, transformer bus group wiring. So we will go through some introduction first. So in the previous unit, we learned the single bus section with bypass connection, which is much more reliable than the single bus section connection, and solve the problem of when the circuit breaker of the outgoing line is overhauled, the power supply of the branch should be stopped. However, the problem of maintenance or failure of the bus of the disconnector on the bus side, the power failure of the whole bus, has not been solved. How to solve it? This is the double bus set connection to be learned in this unit. Wiring characteristics. Two groups of buses are connected through the bus tie breaker 0QF. Each outgoing line L1, L2, L3, L4 and power branch 5QF, 6QF are respectively connected to the two groups of buses through a circuit breaker and two groups of bus disconnector. The advantages of this is high reliability, good flexibility, and convenient expansion. Disadvantage is that the branch will still be powered off when overhauling the outgoing circuit breaker. There are many equipment and complex power distribution devices, so it's necessary to switch the circuit with disconnector during operation, which is easy to cause misoperation. At the same time, the investment and floor area are also large. The operation mode, the bus collar circuit breaker is disconnected, and the incoming and outgoing lines are respectively connected to two groups of buses, which is equivalent to single bus section operation. When the bus coupler circuit breaker is disconnected, one group of bus operators and one group of bus stand by. Two groups of buses work at the same time. The bus coupler circuit breaker is closed. The two groups of bus operate is parallel, and the power supply and load are evenly distributed on the two groups of buses, which is a common operation mode of double buses. Typical operation we have separated into this, and you can read it about it. And also we have a double bus section wiring. Wiring characteristics: the section circuit breaker for bus 1 is divided into two sections, and each section of bus is connected with bus 2 through bus tie circuit breakers 01QF and 02QF, respectively. This kind of connection has higher reliability and greater flexibility than double bus connection. And then we'll learn about wiring characteristic, and bypass circuit breaker can replace the outgoing circuit breaker so that the line power supply will not be affected during the maintenance of the outgoing circuit breaker. Advantage and disadvantage. The working reliability of the main wiring system is greatly improved, but the circuit breaker is also used as bypass circuit breaker, and the wiring is economically. The reliability is reduced in the routing process. And 4, we will talk about the no-bus connection. We'll go to the bridge connection and the unit wiring. In the last unit, we learned the wiring of single bus, double bus, and 1.5 circuit breakers. The bar wiring is with bus. Is there a wiring mode without bus? Double bus connection and 3/3 circuit breaker connection have high reliability and good flexibility. At the same time, the power distribution device is becoming more and more complex, covering a large area and high investment costs. In urban 110 kV substation, there are often only 2 incoming lines and 2 transformers at the same time. In the case of an inch of land and an inch of money in the city, is there a simple wiring mode for distribution devices with high reliability, good flexibility, and a small floor area? This is the bridge wiring we'll learn in this unit. The bridge connection. Bridge wiring is applicable to the device with only 2 transformers and 2 outgoing lines. The wiring is shown in the right figure. Only 3 circuit breakers are used for bridge wiring according to the different position of bridge circuit breaker 3QF. It can be divided into inner bridge and outer bridge wiring. And internal bridge wiring, the bridge circuit is placed inside the circuit breaker. At this time, the line is connected to the bridge contact through the circuit breaker and the disconnector to form an independent unit. And also have external bridge wiring. The bridge circuit is placed outside the circuit breaker. At this time, the transformer is connected to the bridge contact through the circuit breaker and disconnector to form an independent unit. And we'll learn, this is the scope of the application, and you can read about it. And also we'll learn the unit wiring. The unit wiring means that is to connect different power elements in series to form a unit and then parallel with other units. And the advantage and disadvantage about it is that simple and clear wiring, less electrical equipment, simple power. But any component fails or stop running after maintenance, and the flexibility is poor during maintenance. And this is the scope of it. And also the wiring features that the unit wiring composed of 2 generators and 1 transformer is called expand unit wiring. And 5 main wiring cases of power plants and substation. The main electrical wiring case of hydro plant, main electrical wiring case of thermal power plant, and the main electrical wiring case of substation. And we'll show you the picture directly, and you can read it after class. And now we have a little summary. In this lesson, we have learned the main electrical wiring we have separated into with bus and no bus. And with the with bus, we have separated into single bus and double bus. And with no bus, we separate into bridge type wiring and unit wiring. And all these different types of main electrical wiring has been learned in the previous lessons. And you can remember this chart and it will help you memorize. Okay, thank you for learning. This is the whole lesson for today. Thank you.